Okay, hey everyone. Welcome to the Miovision Risk Report webinar. We're going to spend some time today going through a risk report, obviously, and we're gonna talk through some of the components of it. My name is Brent Rogerson. I'm the Director of Solutions Engineering at Miovision, and I spend a lot of time with our customers really understanding different challenges that they face, whether that be intersection management, traffic operations, detection technologies, adaptive technologies, and some of our newly acquired through acquisition, some of our new apps that we're going to be exploring integrating to our platform. And today we have Craig Milligan joining us from the safety team, and he has recently joined us through an acquisition of microtraffic into the Miovision platform. So maybe Craig, maybe you can go ahead and introduce yourself and tell us a little bit about your journey so far.
Hi everybody, my name is Craig Milligan. I'm a road safety engineer and road safety product manager at Miovision. I was the co-founder of Microtraffic, and we're going to be telling you about the types of reports that we invented and developed there to help identify engineering solutions to road safety problems. It's a tool based around near miss that's been used in more than 100 cities to help improve safety, and I look forward to telling you about it today.
Awesome, really exciting. Thanks, Craig. So yeah, I mean, we'll kind of dive right into it and start going through some of what a risk report or a near miss analysis type data set actually looks like. I do have up here on the screen a report that was developed for the city of Los Angeles, looking through a particular scenario that was occurring. Maybe to kick us off, Craig, maybe take us through what was going on in the city of Los Angeles and tell us a little bit about what steered them into conducting this study.
Sure, great, and I want to thank the city of Los Angeles for giving us permission to share this report. Los Angeles, like many other cities, has adopted Vision Zero. Then they identified a high injury network, which were locations having more collisions than normal, and they want to put some money into the high injury network. But before doing that, they want to precisely understand the problems and understand the problems that not just the ones that have showed up in the crash data already, but the ones that are impending problems, that there's a risk factor and that it's just a matter of time before someone gets killed, so that they can really bring a holistic safety improvement plan to that intersection. So they engaged Microtraffic. I mean, they saw about the technology at a conference, and they said that's a perfect complement to our crash-based analysis. And they contracted with us to do 98 intersections where we'd get this near-miss risk data report. And then as we get those over to them, we're in process. We've finished 25 of them, including this one. Then they go and select the countermeasures that respond to these risk factors. So that's how Los Angeles got into it, and again, I'm thankful we can share the risk report from South La Brea Avenue and Adams Boulevard today.
That's great. So just quickly on that, you talked a little bit about the process to get to countermeasures. Maybe expand on that a little bit. What's the process to get the data you need? How do you get to, and obviously we're going to be talking about near miss analysis, so a little bit of my question is the video deployment, the process to get to the analysis piece. Kind of give us like a high level overview of what the process is to get to those countermeasures.
Sure. So this risk report is produced from about 60 hours of video, which is spread across 3 to 4 days. So someone might record for 20 hours, 3 days in a row, or 15 hours, 4 days in a row. And they'll often put up 4 portable cameras at an intersection, 2 to 4 portable cameras, and record those. That just covers the different angles and the different areas where people can get in near misses. By far, the most common camera that gets set up is a camera that's purpose-built for this, called the Miovision Scout camera. And what that is a camera with a battery pack, a video recording unit, and it's got a telescoping pole. And you just strap it to anything vertical and physical at the roadway, and telescope that pole up. The camera's on top and is just monitoring the road for those few days of the study. It's the most common camera used for traffic counting around the world. And at Microtraffic, 80% of our customers were using that camera. Some cities will own a handful of those cameras, 5 or 10 or 20, as some cities rely on contractors who have, and these are companies that have formed around that Miovision Scout. They may own 100 of them, and they service the municipalities in their region. And so the first step to get the video, either that city is putting out the cameras that they own and then retrieving them, or they're calling one of the video collection contractors if their municipal area has one to collect video for a site. And we will help create a camera placement plan to say where the camera should go for that intersection. The video gets sent to us, we process it, we extract the near miss data, and we'll show that in the risk report in a moment here. And then we send back this risk diagnostic report after doing quality assurance and quality control on the data. And Los Angeles is using a mix of both. So they've bought a bunch of the Scout cameras, and they also have contractors when they're too busy or all their Scouts are deployed on other projects. There's local contractors that can put up cameras, take them down.
That makes a lot of sense. I'm kind of just curious. What have you seen? How often do cities do a report like this? Is it becoming a more common type of analysis, or is this still fairly new type approach?
You know what? It was very new 5 years ago when we started. Some universities were experimenting with it, but it is getting much more popular right now. And just, I can't tell you exactly how often cities do it, but I was just at a regional ITE meeting, the Canadian region one in this past week, and every day there were 4 or 5 sessions where someone was talking about using video-based near-miss analysis, and it's really an approach that's being adopted en masse right now. And it's not this right now is not something like a traffic count where you'd say, okay, we have 600 intersections in the network, and so we're going to count them on a 4-year cycle. 150 intersections will do a count per year, which is a low-cost study, and you do that, and because the work out of that is to retime the signal, which is work, but it's not that much work. You probably want to do a number of these that you can actually respond to, and so you can proceed to countermeasures, which they could be low cost, they could be medium and high cost. So cities to do 10, 20, 30 per year seems manageable, that they can follow that up with the safety improvement actions at that intersection afterwards.
That makes a lot of sense, because I guess, what is the relation? Because you mentioned this earlier. Often they look at the crash data first, and they almost work their way backwards from crash data. But this being a more predictive measurement tool, being proactive, do you see it being applied to locations that have high frequency of incidences, or is it not really related in any way, and it's more so where they believe there might be scenarios or complaints coming in? I guess my question is, what is the relationship to high frequency of incidences with near miss analysis?
So the near miss data complements crash data. Crash data definitely shows us stuff, and there's a few different ways it adds value. One is to confirm and clarify with precision what issues exist at a location you've already flagged with crash data. Okay, that seems like it's reactive, but it's still proactive, because it's uncovering the other issues at that same intersection that have not yet materialized in the crash data. And then the other way is the crashes just haven't happened yet. Maybe there's been complaints, some other reason that intersection has been selected, or there's a capital works program going through that corridor, and they say, well, we're just going to do the near miss because we have crews there, we have construction, we're going to do the design of this corridor. Are we just going to do a like for like replacement and repave this and refresh the signals with modern equipment, or are we going to make some changes? So they may select it in intersections that are along a capital reconstruction corridor to clarify if there's safety issues that need to be addressed. So sometimes it can be driven by crash data, sometimes it can be driven by complaints, sometimes it's driven by what's on the capital program.
That makes a lot of sense. I was just curious about that, so it was great to hear your perspective of it. One last question I'm going to ask you, and then let's get into the meat of the report and why we're actually here. But many tools today, including the Miovision tools, capture red light running data. They capture data on compliance, signal compliance data. Obviously, you have on one end of the spectrum, you have crash data of incidences that are tracked often through the police departments and things like that. Then there's these almost pseudo safety metrics like red light running and PED compliance type charts. Then right in the middle where you actually can see what is happening is the near miss analysis. Do you find all these tools are complementary, or do some have more? Is red light running complementary to the analysis, or is it more of a way to pinpoint where to do the analysis?
I think it's complementary. Yeah, crash data. I mean, first we categorize into crash data and surrogate data. And near miss is one type of surrogate data. Speeding is surrogate data, red light running, pedestrian non-compliance. These are all surrogate data points. I think it's important when choosing a suite of surrogate data products, just to make sure that if you're going to use something as a surrogate, it's based on the idea that that surrogate is telling you that the real outcome is coming, right? The outcome that you care about. We don't care, no one cares about near misses per se, except if that near miss is correlated with the likelihood that an eventual injury crash is going to come. And so I just choose a suite that has a predictive link between the frequency of that surrogate occurring and then the eventual likelihood that an injury crash is going to come. And compliance and red light running and kinetic energy based near misses. Not all near misses are good predictive surrogates, but kinetic energy based near misses are extremely accurate in predicting the likelihood of a future injury crash. So it is good for agencies to use a suite of surrogates as predictive leading indicators if they're scientifically sound.
That makes a lot of sense, and great explanation. Thank you for that. So maybe with that in mind, let's maybe move into the meat of the report and kind of unpack some of the data points and even relate it to some of the things you've just mentioned. We're open here. I have, and we're going to start going through this. Is actually the report that was provided to the city of Los Angeles, and we'll just scroll through it and we'll talk through it as we go through it. The data in here, and maybe you can guide us through a little bit, because this is ultimately what the customer would receive at the end of the analysis, and this is the finished product essentially at the end. So it'd be good to help our customers understand really what they're going to be receiving at the end. Maybe you can help me, but my first question would be, and the first thing I noticed when I was looking through the report, and maybe an easy spot to start, is just conflict types. You talk in a few different ways throughout this report of what types of conflicts you're capturing between vehicle versus pedestrians and vehicle versus vehicle. How do you view these two different types of metrics? How do you measure them, and what weight do they hold in your level of severity measurement?
Sure. So if you look at the upper half of this screen, is talking about when we say a left hook, a right hook, a through near side, or a through far side. These are the generic prototypical conflict types we measure between vehicles and vulnerable road users. And we will measure them for vehicle PEDs, vehicle bikes, and vehicles and e-scooters. That adds up with 3 modes and 4 conflict types and 4 approaches. That adds up to 48 different configurations that we'll measure. And we measure them and classify their speed threshold or their threshold of risk based on kinetic energy based factors. So the amount of time separating the road users is one dimension, showing their proximity. The speed of the vehicle, the angle, the level of vulnerability of the road user, and the order in which they interact. And those go in together to classify them into different risk levels. and it's according to the impact speed at which the pedestrian could get hit or the cyclist, and the probability of a MACE level 3 or higher injury, which is a severe injury. And so if we say medium risk, that corresponds with a certain probability of injury if that would have materialized into a crash. And we're not just telling you it happened, we're telling you the exact configuration. And so we'll report out, okay, 0 or 10 or 15 of these near misses happened during the observation period. And it's just, you'll have data on these 48 types for vehicle versus vulnerable road user, and we'll show you kind of how the data breakdowns occur later in the report. But often in the crash data, it's very hard, and thankfully, it's hard to find clusters of pedestrian crash. You may have 1 or 2 at the intersection, but there's actually 48 different ways that a vulnerable road user could get killed at the intersection, and most of them will have 0 data on it because it just hasn't happened, because there's no risk, or because there is a risk and it hasn't happened yet. And with these, we uncover those places where there is a risk and it hasn't happened yet. So that's the vehicle versus vulnerable road user. And then the next one is vehicle versus vehicle. And if you just scroll to the second half of this page, there are 3 generic conflict types times 4 approaches. So we report on 12 different vehicle versus vehicle risk configurations. And you see these are all relatively involving movements at right angle or near right angle impact. These are not the only crash types between vehicles at an intersection. You know, a side swipe could happen, a rear end could happen. We feel that 1, those are lower severity crash types, and 2, the crash data sample sizes are often pretty high on those. So you don't need to complement the crash data with near miss data. And to get the rear end crash or conflicts, you would need to put cameras up along the approaches because rear ends happen across, they could be happening on a 200 to 600 foot approach. And just for practical, that would just drive up the cost. So we don't typically measure those. And these, again, the severity level of these is going to get reported based on the speed, the impact angle, which side of the vehicle is getting hit, and it's all ties back into injury biomechanics, so that based on that injury severity, there's a predictive correlation, or based on the conflict severity, there's a predictive correlation to the likelihood of an injury crash. So those are the conflict types. There's 48 in the vulnerable road user category and 12 in the vehicle category. 3 types times 4 approaches is 12. That makes 60 different, the 48 and the 12 is 60 different risk factors, which we will present the exact risk level, time of day distribution, and some of the various stuff we're going to show later in the next part of this webinar. So those are the conflict types.
That was really helpful. Thank you. It was kind of apparent as you were talking through that severity, looking for the ones that are going to cause the most amount of injury is the most important finding that you're looking for, the severity that will cause injury or fatality. And I'm assuming that speed's a large factor of that in actually calculating that, because obviously the faster you go, the more the biomechanics comes into play. In your technology, just from a technology question, is that a relative type measure that you do from the video? Is that a technology that you developed to actually come up with that kinetic energy model?
Yeah, you're right. Speed is one of the biggest determinants of severity. Okay. There's an Australian road safety scientist that says road safety is the management of kinetic energy. It's nothing more and nothing less, because any person that's ever died in a traffic crash, they died from the dissipation of kinetic energy creates impact forces. And kinetic energy is the amount of kinetic energy rises with the square of speed. So if speed goes up by a certain percentage, the kinetic energy is going up by a lot more percentage. So it's a quadratic relationship. So speed is a huge factor. Now, you asked, Brent, about our technology. Yeah, we measure the speed of every road user. and that is a special kind of computer vision that does that. If you are onto new technologies on LinkedIn, you'll see all kinds of stuff like YOLO and computer vision and object detection. So we do detection, tracking, and then spatial translation, which we kind of undistort the video and project it onto the ground plane and find the ground center of each road user, to the point where we have each road user speed to within a 10% root mean square error. It's not enforcement grade speed accuracy, but it is enough to calculate the risk severity of a crash, and it's a pretty special to be able to do that from monocular video. A lot of other speed measurement technology would use like a radar or a laser or something like that to get a signal bouncing back. So to be able to get that from the video was a big accomplishment that unlocked the use of the kinetic energy based approach.
Yeah, absolutely. And that kind of answered my second question at the same time, is to some degree, is obviously you've chosen video as your main source of data, and video obviously versus other technologies like lasers or LiDAR or whatever it may be. Aside from being able to come up with that model, do you see just there being more benefits in general from using video for this type of application versus other technologies?
Yeah, reasons why we chose to work with video. One, it's a ubiquitous and low-cost sensor. Two, the engineers we serve can actually review the clips of the events and understand what happened. Three, we protect privacy, even though it's video, by blurring faces and license plates, and often the resolution is such that you couldn't even see it before the blurring. I'd say the fourth is that video is by far a better technology for really reliable classification of road users. So a radar, is very hard for a radar to tell, is that a pedestrian or bicycle or a motorcycle, but the video has the shapes, the edges, the visual features that the neural networks can use to accurately classify the road users. I think these other technologies are very interesting and will play a big role in smart cities going forward, but video was the best technology for us at this time.
Yeah, no, that's great points. I mean, obviously, Miovision being a video-based company, we chose it for the exact same reasons. You can do the classification, you can see the objects, you can teach the objects to do more things over time. And you even mentioned scooters earlier. Being able to just recognize different types of emerging trends like scooters on the road can allow you to evolve your analysis over time quite quickly.
Yeah.
So to kind of go back to, you mentioned severity a few times. So what I was hoping you could help us with is maybe just take us through some of your findings at this particular intersection and kind of take us through the report. I don't know where it would make sense to start there.
Yeah, let's pause right on this one. And could you just zoom out by one click, zoom out?
Yep.
And then so that the labels are showing. Yeah. One of the first things we show in our report is the number of conflicts in each configuration. So this is a summary chart for vehicle near misses. And on the bottom, you can read the configuration. North left versus south through had the most near misses. About half of them were orange or red, so high risk or critical. And about half of them were medium or low risk, so yellow or green. So this chart, it shows both frequency and severity at a glance. And then you can dig down into a detail page, which not right now, but I'll explain that in a minute. But the severity level, right, we will classify them into the severity level based on the kinetic energy model. And we give you some very nice, if someone asks you what does a high risk versus a medium risk mean, we can say, well, that's between X and Y % chance of a MACE level 3 or higher injury. Or if the person who's asking you is a bit more technical, you can tell them this has this much predictive power that a future injury is going to happen. So the further up you go in this severity scale, the more proximal they are to a crash, and the worse the outcome of that crash would have been. So people take action in response to this based on both frequency and severity. And you can see, you know, at a glance, there's two movements that are really popping out here as having a significant risk in the left turn area, which is north left versus south through, and the east left versus west through. And you need to, then the engineer starts to think about, okay, how can I solve these left turn problems? And there would be a menu of solutions at their disposal that they know of. If they were having crashes of this pattern, they would know strategies how to deal with that. And you would respond to these near misses in a similar way as you would to respond to crashes of the same configuration. So that's severity, and that's the detailed chart. We give this in graphical and tabular form. So the next page is the same data in tabular form. And then there are, so this is the same data from the preceding chart. And then the chart is repeated for the other modes before going into the detail page. At this particular location, you just saw that chart. There was not very much in the way of near misses for vehicles versus cyclists. And then if you keep going to the rest of the summary section, there was a few more near misses, but only in the medium and low category for vehicles versus pedestrians. And so when you look at that report, you look at those few summary bar charts to decide what you want to investigate in more detail. So I might look at this report and say, for sure, those two elevated low left turn movements. And I also want to look at that south right hook movement. I may look at every single near miss if I had a lot of time and a lot of budget, but I can quickly prioritize 3 risk factors at this intersection. Now I'm going to go look at them in more detail and start selecting countermeasures for them. Now we operate, Brent, I should talk about this. This report does not contain any countermeasures. It just shows risk data. The primary idea is that we hand it off to you, you being either a consulting engineer or a city staff person at a Department of Transportation, and you would use your normal methods for selecting the countermeasure. We do offer a professional service of matching countermeasures to these with a team of road safety specialists that I manage, but that would be a separate report than this risk diagnostic report. And like a separate engagement. But our preference is to show you the near miss data, to teach you how to use it, and then you select the countermeasures.
That makes a lot of sense. This being, I mean, we saw even recently at a regional show focused heavily on safety designs and countermeasures, and we saw a lot of very highly skilled professionals creating countermeasures from data like this set. Seeing that just show is very impressive because there is a lot of talented folks out there. Do you find that road safety engineer is becoming a common role at every agency, or is that more of a consulting engineering firm type approach?
I'd say it goes with the size. Like at cities of medium and larger sizes, there's often a safety engineer, and then in that kind of sub 100,000 range, there may be a traffic engineer who has to do everything traffic, and sometimes they just don't have time to dig deep into safety. It really depends on the agency, but I mean, a lot of states have state traffic safety engineer, and then they direct a team of traffic safety engineers. It's a fairly common role, but that doesn't mean they may still hire consultants because they're very busy, right? And there's so much work to do.
Yeah, I guess that's where your professional service can come in as well. If they don't have the capacity or the skills, or they haven't a mechanism to outsource it to an engineering firm,
right.
Your team can help out.
Or maybe they have a mechanism, but a lot of safety engineers are completely booked right now because of Safe Streets for All. So Yeah, we do offer that as a service when we have the capacity to take it on. We will do that countermeasure matching. I see you're scrolling to a detail page.
Yeah, so I know you mentioned this earlier, so maybe the next step, obviously, in your workflow is to get to the more detailed page. So maybe talk us through this a little bit.
Right. So this here you have one of the configuration for actually any configuration on that bar chart that had any risk data. A detail page will get generated for it, and whether it was a lot or a little risk data, this detail page will get created. This was one with a lot of near misses. It was the north left versus south through vehicle, and I'll show you the different parts. In the top left, you have an image. This is just an automatically extracted image of one of the events with the tracking on it, so you can just kind of visually contextualize that in the intersection. In the top right, there is, we call that the risk table that shows frequency, annual estimates, conflict rate, and relative risk by risk severity. And just to explain what that means, like walking down the high risk column, there were 134 measured high risk near misses. We extrapolate that out to an annualized estimate just based on the duration of the study and compared to the number of hours in the year. We provide a conflict rate that is dividing those 134 events by the number of people who made the movement most exposed to risk in that configuration. So the most exposed to risk is the north left vehicle. So we would take the north left volume over the period of the study, and we do 134 divided by that volume, and we find that 2.59% of those north left vehicles are in a high risk conflict. And then moving down to relative risk of 2.25, what we've gone and done is we've taken that conflict rate of 2.59% and divided it by the benchmark rate. So we have a huge database from all over North America. We know what a normal percentage of left turning vehicles is to get in a high risk conflict. And here, the percentage rate is 2.25 times higher than the benchmark. If it was exact same as the benchmark, the relative risk would come out as 1. Any number divided by itself is 1. So if it's lower than 1, it means this site is doing better than its peers. And if it's higher than 1, it's performing worse than its peers. And if it's up 2, 3, 4, 5 times worse than its peers, it's a strong justification for action. Not that you wouldn't do action even if it was below the benchmark. If the rate is significant and the frequency is high, and you can take out that frequency of high risk conflicts, you should do it, even if it's already a bit better than benchmark. So this we think of this as like a 360 view of the intersection. By you look at the number of events, you compare those events to the amount of volume at the intersection, and you compare it to peer intersections to have different viewpoints on risk. And it's not one or the other that drives the decision about installing a countermeasure, it's all of them together. So that's the risk table, and which is stratified by risk level. The not applicable on relative risk under critical risk means that ratio can't be statistically significantly calculated because critical risks are rare events, right? Here, the critical risk, one of those critical risks that happened was a person coming through that intersection at 110 kilometers per hour. So this person should be going to jail, right? Like that doesn't, but there are street racers in LA, like there are everywhere. And so it's just a pretty rare event. And if you're seeing a big pattern of those, you really need to fix that intersection right away. But you can't do the same ratios and comparisons because the data size is usually small. The next section under that is the temporal distribution. So you see when during the day are these events happening, and does the severity profile change during the day? Interesting here, there's a kind of a widely spread morning peak and then a more narrowly spread PM peak. one of the things that's interesting, if you look at 5 o'clock, there's a bit of a peak at 4, 5, 6 o'clock, or 16, 17, 1800 hours. And even though there's a moderate peak in frequency, it goes to the really low severity level. And that what's happening here, the traffic engineering explanation for that is that it's such congested operations, there's low gaps, so people are getting in near proximal conflicts by turning across the oncoming vehicles, but they're going the oncoming vehicles are going so slowly that those, if they did crash, they would not be getting in a serious injury, or there would be a very low probability of a MACE level 3 or higher injury. But in the wider morning peak, there's not enough safe gaps, but it's not so congested that the speeds are higher, and those could be producing more injuries. So it's not necessarily the busiest times of day that are the most riskiest. It's like the shoulder, you can see how the shoulder periods are impacting safety. And you can choose signal timing strategies. I mean, we're talking about left turns, so there's a few limited things that you can do with that. You can go for a fully protected left turn. You can go for protected permissive. If it's already protected permissive, you can modify the timing plan or the start and end times of a timing plan. You can extend the protected portion of a protected permissive split, and this time of day chart can really assist with kind of fine tuning what you choose to do on that. Then the last thing is just a risk scatter plot, and that is just each event that happened. So if you look at the frequency, the 2 and the 134 and the 80 and the 51 in the top table, each of those events is on this scatter plot. It's a real thing that happened. You can watch the video of it. The speeds involved, the post-encroachment time involved, and the risk rating. And you may want to say, like, I want to watch 5 of those videos just to better understand the root causes. We transfer those videos to you outside of this report, time-stamped, and the metadata associated with them is available to you, and you can watch and try and understand, the root cause. So that's kind of how a detail page works, and those detail pages are available for any of the 60 configurations that had a risk event. So sometimes if the camera view is not covering that configuration, or it just didn't happen, that detail page won't be in this report. But if every single configuration had a risk event, you'd have 60 detail pages in this report.
That makes sense. Yeah, I was just starting to do the math on how many pages the report could be.
yeah, it could go up over 70 pages.
Yeah, but I mean, I guess that's a very helpful way to look at it, though, because there's 3 different, you categorize it: critical, high, medium risk, and then throughout the day, because a lot of what you're trying to figure out from this data is what will be my countermeasure. And like you said, in a low speed saturated scenario, there probably isn't necessarily a countermeasure that's related to safety. Maybe you're actually trying to tackle progression, which is more of a signal performance type challenge, not a safety type challenge. But then in the shoulder periods, or in that morning period that we saw, there was a safety issue that was maybe related to better progression because the signals were flowing, allowing for higher speed. So you get to see all the different flavors of the scenarios where you can actually determine what the right countermeasure is based on all of the factors. So it makes a lot of sense.
Yeah, all I was kind of getting at is that depending on, even from the data, you can see that there could be highlighting different challenges, not just safety challenges. So it could be there's a lot of low risk events occurring because there's a lot of signal progression issues actually occurring, which is causing a lot of slow moving vehicles, which you would countermeasure a different problem there, but it's another reflective symptom of issues that are occurring within the network itself. One of the things I was hoping you could comment on quickly, and I kind of just assume this a little bit, but I did see the report here, which I found interesting, is at nighttime when you have very low volume and potentially a lot higher speed scenarios. In your analysis, I guess you try to capture a good range of nighttime, daytime, peak hour times. You try to cover the whole range, and it looks like you did have a nighttime period early in the morning here. But I guess even though it's still at the nighttime, this one here was still ranked as a low risk scenario, but that could be just due to volume maybe.
Yeah, no, if you look at that event on the scatter plot, you'll see that it just occurred at a really low speed, and the temporal separation between the road users was high. So yeah, it works at night. You're right, sometimes at night the speed is higher, but in this case the speed was not high, and that's why it got ranked as low risk. If there is a decent amount of street lighting, this works at night. If there's absolutely no street lighting, we don't operate at night. And if it's raining and there's a lot of headlight glare, it depends a little bit. Some cameras will work at night and some cameras don't work at night. So the night data is very helpful, and the time of day distribution will reveal that, and then you can watch the clips happening at night. You know, you can sort the clips and kind of watch them and say what's going on with this, or do we have intoxicated people using this, pedestrians using this facility, or what? Yeah, or is it the very high to the low volumes?
Yeah, exactly. And that's kind of what I was thinking is during COVID, there was a lot of data coming out on higher speed events occurring because of lower volumes on the road. And you saw that range in the daytime all the way through the nighttime. But then you also saw the restaurants start moving out into the streets and using the outdoor space a lot differently, which changed the configurations of the roads that increased a lot of the risk profiles on the road. I wonder if that's going back now, but generally being able to measure that at all times of the day in a city setting makes a lot more sense now.
Yeah.
Before maybe we move on to the next section, any other data point or chart here that may be worth highlighting? I think we covered.
Yeah, we covered most of it. I mean, one other thing is that I'd just say is that these sections with not a lot of data are useful, because sometimes you get complaint. My colleagues that work in the public sector, they get people complaining, and they say, oh, this movement is really hard. You need to do something about X or Y. And then you can show them, okay, we measured that movement, we measured this movement. That's why we did the treatment on this side and not this side of the intersection, because there's basically no risk here. So it's very helpful in like justifying why you didn't do something as well.
Yeah, that makes a lot of sense. Yeah, no, I totally agree. So if I was a city, how would I go about asking for this study? How do I get this study done, and who do I go to, or what makes the most sense to get this done?
Sure. I mean, on the Miovision website, you can like put in your region and get connected with like an account executive for your region. They'll get you set up to get you a quote for the study, and we will provide a camera placement plan, and we'll just talk about, okay, then who's going to put the camera up? Does the city already own cameras? Do you need to stock up your first few cameras? If so, that'll be included in the quote. And then it's a process of working with the account executive to get it off the ground, and we will be on the phone with you when you put the cameras up in the field to make sure they're capturing the correct field of view, and get you to text message us, our camera deployment team, a view of it. And we'll just be with you every step of the way to get the study off the ground. In the future, one of the things that's coming is you'll just be able to order this kind of study online. Like you can order a traffic count, but we kind of got that process. You guys at Miovision, I say we now because we're part of Miovision now, that process is like a well-oiled machine. You could just, people know how to put the camera up, and so it's very amenable to online ordering. This is not like an online ordering. You talk to someone and we work together to get the project set up and guide you through it. In the future, it'll be online ordering.
Yeah, because I can imagine there's a lot of nuances to where the data is coming from and making sure you get the right data.
For sure, yeah, and camera installation is important to get it right.
Yeah, and so for sure, and maybe just to reiterate, I know you've covered this a little bit. Maybe just quickly, just clarify and state exactly what you get in the report just one more time. Just a nice structure of, so you talk to your executive, we get the camera set up, and then you get this report, and this report includes a series of items here.
The report includes the things we've shown so far in the webinar, which is graphs and tables showing at a glance the frequency and severity of near misses across 60 different risk configurations for 60 hours. And then it shows detailed information for each of those configurations where there were risk events. And the detailed information includes the frequency, annual estimate, conflict rate, relative risk, temporal distribution, and risk scatter plot. Alongside every report, we give you also a link to the video clips so that you can watch them. So that's what's in scope, that's what's included. Video collection is generally not included. You do that, or you hire a contractor to do that. In the basic report, recommendations and countermeasures are not included, but that's a separate report that you can also ask us to do. You just engage our professional services team if you don't have a local consultant or a person on staff with the available time to do it. Yeah, so that's kind of what's in scope and what's out of scope for the report. Yeah, and it's been proven to be a great tool. I mean, LA took this, they put countermeasures in, they modified the left turn signal timing, they did something with the pedestrians, and they did an after study, and they had over 80% risk reduction in the targeted risk factors. So it's this set of data can really help road safety engineers to figure out what to do with improving the safety of their intersection.
Yeah, that sounds great. I can see how quickly you can jump to countermeasures or start understanding what countermeasures could be here. That's great. I have one last question for you, and it's looking towards the future a little bit. Now with the integration of the Miovision team and microtraffic, and obviously we have more possibilities together as a company. Maybe putting on your safety product manager hat on for a second. What do you see the future looking like across portable permanent technologies? What do you see as the future of this technology on the Miovision platform?
Yeah, well, platform is a good word for that, because there's two parts to our platform that I want to relate that to. One is the Miovision One platform. This is a place where you can see all your traffic data in one place and interact with it and manage it in a way that generates insights and actions. So safety data, signal performance data, traffic count data in a map-based view that can see what's going on and basically what you need to do next about the network. So right now we're giving this to you via report. What's coming down the pipe is we will be giving you this data on the Miovision One platform. Okay, the Miovision One platform is released, but we're adding capabilities to the platform, right? And you can even have third-party data on the platform through APIs and stuff like that. The other side of the platform, besides Miovision One, is like the intelligent intersection part of the platform, where we have an edge compute device called the Miovision Core, and we have a suite of sensors that get permanently installed at the intersection. And already these sensors are enabling things like adaptive signal control, emergency vehicle preemption, transit priority, and traffic signal performance measures and detection. So there's a very powerful permanent ITS solution, and we're going to add to that platform continuous safety monitoring, and then after that, continuous safety actuation. So in monitoring, you log on and see what kinds of near misses happened last week, the week before, 2 weeks ago, because they're just continuously monitored. And a continuous actuation, that's like dynamically modifying the signal timing or sending out alerts based on emerging near miss trends and patterns. So that's kind of some of the stuff that's coming up in the future. And it's the existence of these platforms really is why it made sense for microtraffic to jump in and join forces with Miovision.
That's very exciting. I'm really happy to hear it all, and really excited to work with you on that over the coming months and years. And whatever it may be. And so anyways, we'll wrap up here. This was really cool to see, really fun to go through the report and see what the possibilities are. So thank you so much for taking us through that today, Craig, and looking forward to seeing many more in the future. As Craig mentioned, if you want to get your hands on a report and do a study, please reach out to either our website or to your reps, and we'll start unpacking your safety challenges and how we can run some analysis for you and see how we can help out. So I'll thank everyone for listening in and seeing the webinar today, and thank you so much, Craig, for joining and taking us through that.
Thanks for the chance, and thanks everyone for tuning in.
Awesome. Thank you so much, everyone. We'll talk to you later.